Thank you, Iain. And I will try to share the document where we were, with the great help of Maria and Valeria, trying to summarize the questions, and actually there are already some answers popping up. So now it will be kind of a task to go through those questions to different speakers, which hasn't been answered yet in the chat or in the Q&A session. That's one thing. And another thing, I think we have quite some time to open floor for some further discussions. That's certainly possible because we are very good regarding timing. I would like to start with questions to Evangelos, and the question, I will just make this bigger for you so everyone can actually maybe read what is in the document. I hope everyone can see my screen. So I would like to take this question, which I highlight here now. Is the question number 2. In the pollutant limited scenario, was the natural ventilation only available when all 3 pollutants were below the limit? If so, which one had the most limiting effects?
Yeah, that is correct, but only for the ventilative cooling function. That means that they didn't permit the window to open completely to have high ventilation rates, but always the window could open a little just for hygienic ventilation to remove the indoor CO2. So then the effect was mostly because we opened the window during summer, and the ozone was critical for this locality that we investigated. So it was mostly closed because of the high ozone concentration during the summer period. I think this can reply this question.
Yes. Then there was a question about the different
yes,
particles.
Why we focus
maybe we
on
can take
PM10,
this one in plenum now. Yeah.
Yes, why we talk about PM10 and PM2.5? Yes, this is correct. We only focused on PM10 because for Lausanne we didn't have data for hourly concentrations of PM2.5, so it was not possible to do this analysis, but we will continue expand the study in a lot of European cities. So we have data from more than 50 air quality stations that measure PM2.5, and we will have results soon for other cities, and we expect to be more interesting.
Evangelos, do you want to elaborate also on number 5, just loud?
Yes.
I would say.
So yes, we took for the deposition rate, each pollutant was made an assumption based on previous related studies of similar building typologies. So all the deposition rate and the penetration factors were assumed based on this. So we didn't assume any specific material, or we didn't go further in this analysis, but we plan to do a sensitivity analysis to see if these assumptions we took for the penetration deposition rate influences significantly the results.
Yes, and then there is this number 7, which maybe we can also take, and maybe we can have a discussion about that. So dealing with the maybe I will just read it. An important factor which can have an impact on the potential ventilative cooling is the external acoustic environment, which can be very different between the traffic and the background location. Is the impact of the outdoor acoustic environment on the indoor sound space and ventilative cooling somehow considered in this research and in general within the annex?
Yeah, it's really nice comment. Yes, and also maybe the acoustic environment, the outdoor acoustic environment influences more the natural ventilation potential than the air quality environment. So yes, we didn't find hourly data that we have for the outdoor noise levels. Only we have some average noise levels, noise pollution for the European cities, and I shared the link from the European Environment Agency that you can find this data. So I couldn't include it in my study as like this. You only have a data to see if a location can apply natural ventilation if it's close to a very busy road with high pollution, noise pollution levels. You just need, as a designer, to consider a different ventilation strategy for your building. So in our model, we wanted to compare dynamically the effect of pollution and the ventilative cooling, but it should be for sure considered in the building's design.
I just, when I read this, it pops in my mind that the acoustic environment is actually also important when we have a mechanical ventilation. It's one of the most limiting factors. Why would people not use ventilation? Because the noise it creates, it's something which they found disruptive. And then it can be questioned, okay, maybe the natural ventilation actually will be kind of less disruptive in some cases for the people. Of course, not in the middle of the city, close to the trafficated road. Then there is another question which I think we can still take. Implementing natural ventilation in polluted country may not be easy. Can we use in a room filtration with natural ventilation, and how to size the capacity of the portable cleaner? That's for Evangelos, but maybe Iain would chip in.
I mean, it's very interesting, but for me, it's you should limit the source at the pollution source at the source. So putting an air cleaner to while you have the window open and you have a huge penetration of pollutants, it's not very effective way to solve this problem. So that's my comment on that. And yes, it can be very difficult to apply natural ventilation, healthy natural ventilation in very polluted sites.
Yeah,
please.
This is Iain. I agree. If you open a window, you're going to let in all the outdoor contaminants, right? And trying to filter them away, I'm going to just agree again. I think it's not practical. That's not to say that filtering in rooms is ineffective. I think if when we've had a lot of troubles with wildfires in the US in the last few years, and I know other places in the world also. And putting a portable filtration unit in your home, they work really well. I mean, they really do. All the tests we've done, I classical scientist thing, I did it at my own home, right? I monitored my own particle concentrations, and many other people have to. They are very effective. But if I was to open a window in a room with my air cleaner, then it would not be effective anymore. So I think the preceding comments are all absolutely correct. That you're not going to be able to. You similarly, you couldn't remove ozone if ozone was coming in any reasonable way through an open window.
It's certainly not a solution which you would have as a standard solution or something like that. Yeah. Okay, thank you. I think we move to Bart and his presentation. And the first question is maybe for a bigger discussion. I don't know. What is the MPC potential when we talk about residential ventilation? And it's also the annex is having the residential ventilation in the title. So what can we get for residences from the experience with MPC in offices and other types of buildings?
Yeah, I think for residences, the main problem is more the occupant use. That's really hard to predict. So therefore, MPC can be really difficult to implement, as occupancy use is quite uncertain in residential buildings compared to non-residential buildings where you have more fixed schedules of use. So in my opinion, that's limiting the use of MPC for residential building ventilation. Of course, for other type of HVAC systems, MPC can be more beneficial for residential buildings. And yeah, also if you look at the pollutants I controlled was mainly CO2, so that's fast reacting. So, but maybe for other pollutants, but I'm not an expert on that level, but for slower reacting pollutants, it might be a bit more potential. But in general, it's mainly the occupancy uncertainty in the use that's the hardest in practice.
Yeah, when I think about this question, on one hand, if I imagine my family, then our schedule is actually quite predictable. It's almost like an office building. Just in the afternoon, you know, you come, you do the same things all the time. But I was thinking, but it's true that there may be cases where the occupancy is highly unpredictable because the people just live their lives that way. Yeah, I think maybe MPC could be more easily applied to other part of the residential systems, like heating, for example. Iain, do you have some further comments on that, or someone else?
Yeah, you just said what I was going to say, is that in residential, we've seen this with smart learning thermostats, right? That learn your residency patterns from the temperature that you set. So it seems to me maybe for some residential occupancies, certainly at Jakub's house it would work. We could have some sort of controls like this that would work. I mean, you're right, probably not all the time, right? But maybe in some homes.
Yes. Are there? I think a lot of the questions to Bart were actually answered quite quickly and swiftly in the comments. I would have just one comment, and that's maybe more for my lack of knowledge. It's a question number 5 about reducing the search space. Do you think that it's mainly about the optimization algorithm? Do you think it would be to the benefit of the study using some of the techniques to actually, or is it just the amount of time you use on the optimization task?
Ooh. Yeah. So yeah, I explored both linear and nonlinear approaches, and yeah, what you see in nonlinear is, especially if you use search spaces, yeah, it takes a lot of time and it makes it quite complex. Especially if you have multi-zone buildings with a lot of parameters and variables, it can be quite complex to solve. For example, it might, as we have seen also in literature, for example, PSO algorithm can be quite effective. But yeah, there's room for future research, especially in the optimization.
Okay, thank you. We move to Klaas. He's ready, I can see. There is a question to you. What are the reference ventilation systems? Is your assessment methodology dedicated to smart ventilation, or could be used also for reference systems?
Well, I try to decouple the pollutants and the scenarios with the ventilation system as a whole. So the reference systems, if I say, like I showed them in the presentation, it's the prescribed ventilation systems like we have them today in Belgium. So it's just based on room square, the area of the rooms and the specific function. So if it's a bedroom with a certain area, it's this amount of ventilation. But we have different kinds. So we have balanced systems, exhaust only systems, and then even natural ventilation systems. So the reference I showed is one of those, but you could also use well, different kind of layouts of the ventilation system and try to explore those as well. So the framework, like I implemented it now, it's in Modelica. So you could even go even further and look into air cleaners and add those in the simulations and see what that kind of effect, well, if you implement those correctly, what that effect is on the broader energy use. So you could expand it quite easily, actually. Yeah, it's by decoupling the metrics from the actual methods, then you can just reuse the metrics for all kinds of other research as well.
I have actually another question to you, Klaas. You were showing the case Belgium in your presentation, and I want to elaborate a little bit more on that. So how is it? What is the plan with implementing this in Belgium? Should this be, because I know Belgium has already quite advanced way of assessing new ventilation systems, for example, and so on. You have these different categories from A to all the way down. Is this the next step? Will it be implemented in a legislation, or what are the maybe more long distance? But what are the plans?
I hope so, that it's going to be soon, but there is a revision of the current ventilation legislation. Well, it's planned, let's say, so there is research going on. And well, I hope, of course, with my results and my insights to aid into implementing that. So it's not for something for within 10 years, it's more something for within 1 or 2 years, I hope. And so it's but it also depends on the European legislation, because, well, kind of waiting for that to be finalized first before you can start on the national annex to it. So it's, of course, is, well, it depends on what ends up being in the European legislation, where you can really start making your national annex, of course. But for the specifics, it's not only Ghent University, of course, that has something to say into how that's going to work. But I see that I only see one question here, but I have others here as well in like my Q&A box.
Yes, I think we are running a little bit over time, but I think still we should pay attention to these questions also. We also started a little bit delayed, so I think we can allow for that. So could you please take the question from there, because I cannot see the box myself.
Yeah, okay. Well, one of the questions was if I'm accounting for uncertainties in my calculations. So if I use Monte Carlo or something, another kind of approach. And the quick answer is yes. So in the current method already, so the one with only comfort, we do Monte Carlo analysis. So we don't have one family, but we have 100 families that live in the same house. So we have variations, and sometimes it's someone just living alone, and sometimes it's a family of 4, or sometimes there's a baby or children. So we variate the occupancy, well, to account for, well, to try to account for a broader view on what's in Flanders or Belgium for occupancy. For my sources at this point, I don't use uncertainty calculations yet, but I hope to do so. But the problem is, the more you do so, the more simulations you need, and then we will get into trouble if we want to evaluate a system. We might want to wait. We don't want to wait like 2 weeks for the results of all the simulations and our analysis. So at some point, we will have to find a trade-off between how much simulations do you do and how long does it take to do them. And then another one.
Yeah, let's take one more, and then we try to jump to Iain. Yeah.
Yeah, perfect. It's a small one, so it's not going to take that long. It's more for the DALI method. So the question is, did I use for the ID method, if I used the publication of Huybrechts, which is the one that Jennifer Logue also refers to? The answer is yes. So that's if I do the IND method is a preferred method, but if it's not available for all the pollutants, I include it. So as a second choice, we took the ID method, and then we looked at the values of Huybrechts et al. For the inputs of the calculations.
Yes, thank you very much. Iain, I didn't get any questions in the general Q&A. So one thing is that we can look into your personal Q&A or your personal chat, whether there are some questions. But I would like to start with a general question from me, or one question from myself. When you talked about that the ideal case would be to find optimum ventilation control strategy for each house. I like it very much. That's considering all the different where the house is placed, what is the outdoor environment, what is the outdoor pollution, who are the inhabitants, and so on and so forth. But do you think it would be somewhat realistic in the near future in terms of that the designers who work on the home ventilation, they are able to get more advanced tools? And would we be close with these tools to give them actually to the designers so they could tailor the ventilation strategy for almost each individual house?
Yeah, you raise a great point. To say that life is complicated and you're on your own is not helpful, right? We need to provide guidance for manufacturers of equipment and designers and people actually building homes and so on. I think the short answer is yes. I presented an overly complex picture, I would say, but I think that we do know how to simplify this. There are definitely, we looked at many strategies, but really only 3 or 4 of them were successful, and some were pretty good over all building types and all climates. And so you could maybe break this up where you could say, okay, if you just want to take the simple approach, use this simple ventilation controller that's based on outdoor temperature, and it works. It's not the best in every home, but it's going to work well all over. And then you could say, but if you want to use more advanced techniques, here are 3 or 4 other control strategies. And the way you select it is by looking at, okay, how leaky is my house if you've measured the leakage, or what climate am I in? And so you could come up with, I think you could come up with simplified guidance, and probably we should be working on that.
Thank you. So what about do you have some questions which popped up in your chat?
Where do I find the chat that's just for me? I'm looking up. I'm trying to.
It's to the right, low right corner.
Yeah, that's okay.
In the meanwhile, we can open audience for some open questions to Iain.
Yeah, go on.
Sorry, Jakub, but the audience is not allowed to.
They are not allowed. I'm sorry.
They're muted by default.
They are muted,
so,
and they cannot be unmuted. I'm sorry.
I cannot change that. Sorry.
Yes. Then I will allow myself, or let's first allow the panelists, because they are allowed to ask questions. I can see Carsten. Or I will allow myself to ask one more question. You already mentioned the forest fires, for example. So again, more like a discussion topic, ventilation strategies and the future regarding changing climate, having more extreme events, and so on. What would be your thoughts about that? Is there something we miss in our smart ventilation strategies regarding this point? Will there be robust enough when we talk about sudden, very extreme events like you have mentioned with the forest fires? Or are they smart enough that they would simply work well also for such a cases?
Yeah, I mean, you're going to have to, that's basically connecting ventilation to the outside world, right, in some way, right? I don't think it's practical for every building to have its own on-site measuring system for outdoor contaminants. That seems to be an expensive, high maintenance, unreliable way to do things, particularly when most places in the US and Europe have some site that's relatively close by that is, well maintained, using very good instruments, and the data is available online. And so if you can access that data that's available online, that would probably be the best strategy. And maybe you could indeed have a ventilation controller that had some internet capability, that could look online. You know, it would check, say, every 15 minutes or every hour to see what the outdoor contaminants were and say, oh, okay, today's a terrible day, or at this hour, there's a lot of traffic near my house, so the particle concentrations are high, and so I'm going to reduce ventilation for the next hour or so. That's certainly conceivable, but you know, it does add another layer of complexity and expense to our controllers, because now you need an internet connection. And yes, the hardware is inexpensive these days and not too difficult, right? So that's certainly possible. I think that's the only practical way to do it. Like I said, I don't foresee every single controller having a connection to outside of the actual building itself. That just seems really impractical to me.
Mm-hmm. Okay, thank you very much.
Sorry, I thought you were going to ask another question.
No, I think we are now on our way to give the word to Carsten, who will close the webinar now, because we are reaching our time slot, I would say. Carsten, please.
Yes, thank
you very
you.
much.
Yeah, hopefully without echo. The timekeeping has been very good for this very interesting webinar we've had. I think we had some really, I was amazed to see this possibility we have with smart controls, smart ventilation, to really, in this balance between energy use and indoor air quality. I'm amazed to see what possibilities we have, but also the challenges. And I kind of understood that if we adapt the possibilities, then we have some options. We have some ways to go, but we are not there yet. And also with the project, we are not there yet. As I said in the beginning, I tried to say in the beginning, the project is running until the middle of 2024, so we have 2.5 more years ahead of us. Also, I'm amazed to see the great interest. So we have a lot of participants in the project, but we have had a lot of participants in the webinar here. I can tell you that we were 170 participants around for most of the time. So that's been fantastic. So from my side, thank you to the speakers here for nice presentations. Thank you for the audience for participating, and also for the questions that were asked. And also, I should say thank you to the AIVC for making it possible to have the webinar, and also for following up that you can see the webinar afterwards, along with the previous webinars we've had already, and that we plan to also to have for the continuation of the project. So thank you to everyone for that. As we all sign out here, you will get also a questionnaire to assess the webinar here. So please fill in that as well. We hope to see you. Please make contact with us about these interesting things here for the next 2.5 years. So from my side, from everyone's side here, thank you for now, and look forward to being in communication with you also for the continuation. Thank you.